All right, here's warm-up number 54. The sum of the interior angles of a regular polygon is 7,920 degrees. Okay. All right, so how many sides does it have? That's going to be the n, right? So I'm going to use in the formula n minus 2 equals 180 degrees. Okay, so I'm going to plug, I've got the sum here, that's the 7,000 number. Okay, and I'm going to solve this for n. You could distribute the 180 if you like. I prefer to just divide by 180. I think it just goes quicker. Okay, and then 7,920 divided by 180 comes out to exactly 44. By the way, if you ever get decimals or fractions on these for n, then something's wrong because you're never going to have 3.7 sides. It's always got to be an integer, right? So then I add 2 to both sides, and n is going to equal 46. So 46, that's the number of sides. Okay. Now this says that this is a regular polygon. Regular means that, that doesn't actually matter yet. Sorry, I'll get back to that. I was jumping ahead. But the number of interior angles, if you think about a square, it has 4 sides and 4 interior angles. A triangle has 3 sides, 3 interior angles. The number of sides is always the same as the number of interior angles. So 46. Okay. Sorry. Number 3 is where the regular part comes in. So regular means that it means that all the sides are congruent and all the angles are also congruent. So here's an example of a regular triangle, which would come out to be an equilateral triangle, or equiangular if you want to think about it that way. Okay? But that means when you're finding the measure of one of the interior angles, well, all of the angles have the same measure, so you can divide them up evenly. Okay? So if my sum, what I can do is take my sum. So here, let me write it like this. One angle is going to equal the sum of all of these divided by the number of angles, which is the same as the number of sides. Okay, this only works for regular polygons, but this is how we can do this. Okay, so the sum of all of them was 7,920 degrees, and there's 46 of them, so they're going to be divided evenly between those. And then this doesn't come out to an integer, but that's okay because this is the measure of an angle. So this is about 172.17 degrees, somewhere in that ballpark, a little over 172 degrees. Okay, and then one exterior angle, we're going to do the same thing. We're going to take the sum of all the exterior angles and then divide by how many exterior angles there are. So the sum of all the exteriors, no matter what kind of polygon it is, that's always 360. Okay? And then the number of exterior angles is the same as the number of interior angles. So here again, I've got 46 of these, and this again will come out to a decimal, but that's okay. It's the measure of an angle. Okay. Okay, the next problem says, are the following figures definitely parallelograms? And explain. My explanation is just going to be the theorem that I'm using. And my numbering's off. This is supposed to be A, B, C, and D, so I'm going to go ahead and change that. I'll try to change that on the form. Okay, so I'm looking, are these definitely parallelograms? Not, they all might be parallelograms, but there's only certain ones that definitely are. So if you look at this first figure, I know in a parallelogram the diagonals bisect each other. But the converse of that is also true. So in a quadrilateral, if the diagonals bisect each other, then it definitely is a parallelogram. So my answer here is yes, and my explanation, that's the converse of the parallelogram diagonals theorem. Okay. All right. Next one, I have a pair of opposite sides that are congruent, but that's actually not enough. So this is going to be a no. because, you know, just to emphasize the difference here, I could have something like this. That's obviously not a parallelogram, but the opposite sides are congruent, okay? But if the opposite sides are congruent and parallel, then the only, so like on this last picture, if I made these opposite sides parallel, well then it would look like a parallelogram. It has to be a parallelogram if one pair is both parallel and congruent. So this is called the opposite sides parallel and congruent theorem. Not a great name for a theorem, so you could just explain it in your own words and that would be fine with me. Okay, and then the last one, I've got a pair of opposite angles that is congruent, but these are supposed to be congruent, but that's not enough. And I'll try to show you with a sketch. So let's say I could have these two angles be congruent, but obviously it's not a parallelogram, right? Those theorems don't work with B or D, okay? And that's it. See you next time.